Welcome back. Sorry that last video ended abruptly. Um, these things happen. Uh, where we were left off was we were talking about uh, keeping track of a new metric, which is how many bikes, how many times do people arrive, want a bike, and are unsatisfied. Um, what we realize is we have this metric, and what we want to talk about now is how might this metric depend on some input parameter. So this is moving into chapter 4 now, uh, and I want to compare two different scenarios. Uh, First, we've created this run simulation function that kept track of the number of bikes at Olin, and that changed over time. Right, so we created this simulation, we defined the run simulation, we created a time series to keep track of the results. We populated the first entry, and then we kept track of the results over time. When we were doing that, all we needed to have in terms of our state variables, our state variables were Olin and Wellesley. And what we're going to do now is we're going to modify this code in such a way that it has a different purpose. And it has a different purpose because the question that we want to answer is different. So on this purple side, we're running the simulation to keep track of the number of bikes at Olin over time, and we can then plot those results. That's what this last line here does. Right, this last line here plots the results of how many bikes there are at Olin over time. If you look at this, this is pretty specialized, right? If we wanted to plot Wellesley over time, or if we wanted to plot, if we wanted to do something with the information, we're kind of stuck. Everything happens here in this last line, and then we're done. So what we're going to do is we're going to modify run simulation so that it does what we want it to do this time, which is to keep track of the total number of unsatisfied customers. So just like last time, what we need to do is we need to augment our state variable, so our state object. Bikeshare now has Olin Wellesley, but also Olin empty and Wellesley empty. And because we're not keeping track of how many people there are at Olin over time, or anything that's happening over time, we really only care about what's the total number of unsatisfied customers. Our run simulation doesn't need to have a time series in it. We don't need to have a time series because we're not keeping track of something over time. If we did want to keep track of, for example, what Olin empty is over time, we could create a time series for that and collect that information along the way. And that's something we'll be doing later on after the first project. But for now, what we'd like to do is we'd like to run our simulation. We'd like to run the simulation, and what we really care about is just going through all of the steps, all of the time information, and then we want to extract information out of the simulation so that we can do things with it afterwards. So in this code, what we're going to do is we're going to create a return statement. And so we saw return earlier in our bike to Wellesley and bike to Olin when we said there's no bikes, so just return. Get out of this loop. Well, you can also use return to send information. So we're going to use this. This will send the final value of the state object out of the run simulation command so that you can do something with it, so that you can use it afterwards. All right, and so let's look at what a line of code, what the lines of code might look like if we're trying to incorporate this. Well, first we might define our bike share. Bike share equals a state object. Well, it has to have a number of bikes at Olin. It has to have a number of bikes at Wellesley. It has to have that Olin empty is equal to 0 and Wellesley empty. Those are our metrics that we're keeping track of. So we first define our bike share. The next line of code would be we want to run the simulation on this bike share. Run simulation of bike share, comma, we need the first probability, the second probability, and we need the number of steps. But now, because of the way this run simulation is defined, it outputs something. And so we need to catch it. So when we run simulation, we need to catch that information. So we'll catch it in something, maybe we'll call it final, or maybe we'll call it state. We'll have to call it something because we want to collect it afterward. So we're collecting that information, and what we want to do is then access the information we care about. So then we can ask, what is state.olin empty? And so what this does is this accesses the final value of Olin empty here. Okay, so if we go up here, remember, what are we saying? We have a new goal for what run simulation does. Because we're not keeping track of something over time, we don't need that here in the run simulation, so we can just take that out. You could keep it in it if you want. Whether it's there or not, that's not going to impact things. And at the end, we're going to collect the information that run simulation accumulated over time. Okay, so what this will allow us to do, so this will allow us to compare the value of the metric for different inputs. So if we run this line of code, let's circle it. If we run that line of code, we'll get how many people tried to access Olin and were unsatisfied. But then we can change the inputs and we would get a different answer out. So if we could get a different answer in terms of, let's say instead we could change how many steps we run this, or we could change an input parameter, or we could change this input parameter, and we could see how that impacts the metric over different inputs. All right, and to do that, what we're going to do is we're going to use something called a sweep series. All right, so comparing outputs for different inputs. All right, so here's the question. As P1 varies, how does the number of unsatisfied customers at Olin change? So as you change P1, how does that change how many unsatisfied customers there are at Olin? Right, so if we're trying to uh, answer this question, here are the steps that we'll follow. So we're going to create a sweep series object to keep track of the data. Then we're going to determine the list of values we want for P1. We're going to use this new command called linspace, and then we're going to create a for loop to run the simulation for each value of P1. So let's write down the code and then let's discuss it. So we're going to do sweep equals sweep series. So this is going to define an empty container to collect the data. And then we're going to create an array of values that we care about. P1 array is going to be linspace of 0 to 1 with 11 elements. So we want values. These values look like 0, 0.0, 0, 0.1, up to 1.0. This is our list of values, and there's 11 elements starting at 0, ending at 1. All right, so we created a sweep series that's going to keep track of the data that we collect, and we're going to specify which values of P1 we care about. Let's define P2 to be 0.2. This is going to be a fixed number, and we're going to change P1. And we're going to specify the number of steps, and we'll keep track of this for an hour. So here are our variables that we care about. This is going to represent the different values of P1. And now we create a for loop for P1 in P1 array. So we'll change P1 over all values that we defined earlier. We create a state object that comes from running our simulation. Sorry, I missed a step there. So what do we want to do? We're going to take our cue from above. Our cue from above said we need to first define our bike share object, our state object, and then we'll run the simulation on it. So bike share equals a state object that has in it Olin equals 10, Wellesley equals 2, Olin empty equals 1, and Wellesley empty equals 0, mostly empty also equals 0. So we create our bike share, then we run our simulation. State equals run simulation on this bike share with this specified P1, with P2, and with num steps. And then we collect this information in our sweep series. So sweep of P1 is equal to state dot empty, and then we can plot sweep. Okay, so let me highlight some things here. First, the sweep series. This is our array, and it's going to look like, it's going to be a chart. Different values of P1. We're going to get different number of different values for our metric. So when P1 is equal to 0, 0.0, 0, 0.1, 0.2, dot, 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 up to 1.0, we're going to get different values for our metric. So this sweep series gets populated down here. It fills up the information once the simulation runs, and we get the information out of it. All right, the next thing I want to share here is this P1 array. This is specifying what the value is for P1. So for when P1 becomes 0.0, it runs through this loop, and we run the simulation with P1 as 0.0. Then you run and you record that information in the sweep series. Then you run it again with P1 is equal to 0.1. You get the number. You get our metric, the number of unsatisfied customers at Olin, when P1 is equal to 0.1. And you keep doing that. You run through this for loop, and then this final piece here. In the past, our sweep, we had a different plot. In the past, we had a picture of how something changed over time, and in this case, we have a picture where the dependent variable is the probability that we put in, and then get a pen here instead of a thingy. The pen here, this is our metric. So the x-coordinate is the probability, and then we can see how the metric changes over time. Not over time, changes as a function of the probability. I'll create one more video where I go through the Python to show this. All right, see you soon.